All right, my friends, let's look at this fun little plankton problem here. It says researchers on a boat are investigating plankton cells in a sea. At depth h meters, the density of plankton cells in millions of cells per cubic meter is modeled by P of h equaling 0.2 h squared e to the negative 0.0025 h squared for depth between 0 and 30 meters, and then after 30 meters it's modeled by this mystery function f of h, which just had to make your day since they didn't tell you what it was, and then they're just saying that that continuous function is not explicitly given. Tough luck. So anyway, so part A, it says find p prime of 25. This is still the calculator section, so we're just going to do that with your calculator. Here, p prime of 25. Okay, so type in p prime first of all, and then you could do math numerical derivative, and kind of follow your nose with however your calculator has you type this in, most likely differently than my calculator. So you could just get p prime really easily with your calculator without doing any derivative rules at all. So then we've got negative 1.179. And then they wanted you to interpret that in context of the problem. So I would just say this means that when the depth is 25 meters, the density of plankton cells is decreasing at a rate of 1.179 million cells per cubic meter, but then per meter. So you took the derivative with respect to depth, which is in meters, which is why we would do the per meter there at the end. Okay, part B says, consider a vertical column of water in the sea with horizontal cross sections of constant area 3 square meters. To the nearest million, how many plankton cells are in this column of water between h equals 0 and 30 meters? And I'm pretty sure it's about here that a bunch of my students' brains kind of exploded this in 2018. But really, this is something that you can do. And I encourage you, even if they give you something that seems very confusing, push on through, do something, know that you will get partial credit for partially correct answers, and you'd be shocked at what they'll give credit for. Okay, so just do your best to not leave anything blank. Okay, so I'm going to draw a little picture, and the picture is so not necessary to draw, but I'm going to just draw this picture to kind of give you my thoughts here, okay? So you have this vertical column of water, and who knows what crazy, weird cross-sectional shape you've got. I don't know, maybe it could look like a peanut or something. But you've got, what they're saying though is that from 0 down to 30, a depth of 30, you're guaranteed that whatever shape you've got, the area of the cross section is 3 square meters. Okay, so even if you've got, you know, weird peanut shape type stuff going on, they're saying that the area all the way from 0 to 30, the cross section is guaranteed to be 3 square meters. So I'll just say area of cross section is equal to 3 square meters. Okay? All right, so who cares what weird shape it is? We know it's area, okay? So now it says they want to know the number of plankton cells that are in this column of water. So let's think about how many plankton cells would kind of be in an infinitely thin cross-section. So let's start there. How do you figure out how many plankton cells are in any given cross-section? How would you do that? I claim that you would figure, how many, you've got all these little plankton cells in here. How would you figure out how many are in there? So I claim that you could basically take the area of the cross-section, and you could say area, or you could actually kind of say volume, like if it's infinitely thin, so maybe I'll do that. So you would take the volume of the cross-section, and then you could multiply it by the density, since density means number of plankton cells in a cubic meter. So just take density of plankton cells. Okay, and I hope that makes sense. Figure out, take your density, which is number of cells in in 1 cubic meter, and multiply it by the number of cubic meters. So if this is how you'd do it in one cross section, you really just want to add up infinitely many, infinitely thin of those. And so therefore, your total number of plankton cells, pretend that looks like the word cells, in this column all the way from 0 to 30 would be adding up infinitely many, infinitely thin of these little populations. So we're going to add from 0 to 30 of the volume of a cross-section is 3. The area is 3, and then the DH that I'm going to put at the end here is basically, that little height there. And so this would be the volume of the cross-section, and then the density of the plankton cells is just P of H. And now I realize that that's very strange spacing, so I'm going to move DH right there. Okay? So make your calculator do it for you. It's the calculator section, so make your calculator do some work. So we'll do some integration. I believe y1 is still going to work here. We're going from 0 to 30. And then just don't forget to multiply by that 3 there, okay? So we've got, and they said around to the nearest million of plankton cells. So it looks like the nearest million would be 1,675. Million plankton cells. There we go. All right, my friends, I hope this is feeling okay as we go. Now let's look at part C. Part C says, and I'm sure this is like just kind of a day ruiner for a lot of people, but we're going to make this really simple for you, okay? There's a function u. Good times. That's exactly what you needed, a function u, such that f of h. Now remember, f of h is the density function past 30. Okay, so they were using p of h for the density from 0 to 30, and f of h is just the function the density function for lower than 30. Okay, so you've got this u of h function that is always greater than f of h, and they're never going to tell you much about f of h other than it's less than u of h and bigger than 0 for all h greater than or equal to 30. And they're saying the integral from 30 to infinity of u of h dh is 105. The column of water in part B is k meters deep, where k is bigger than 30. Write an expression involving one or more integrals that gives the number of plankton cells in millions in the entire column, and then explain why the number of plankton cells in the column is less than or equal to 2,000 million. Boom. Okay. Again, total day ruiner, but we're going to keep this really simple for you, okay? So we were supposed to use, so from 0 to 30, we were supposed to use the density function P of H, okay? And we did. But then after 30, we're supposed to use a different density function, the mysterious F of H, okay? So it's the same column of water though, so the a cross section is still has an area of 3 square meters, okay? So moving on to part C here, if you want to know the number of plankton cells in the column of water, that is K units deep. So I'm going to say K is, and I'm going to point out, make sure K, we know K is past 30. K meters deep, I guess I should say. How are we going to do that? Well, we already know to the nearest million how many plankton cells are in the 0 to 30 piece. So that's what we found already. So we know that much. And then plus, we would need to add up, infinitely many, infinitely thin of, the amount of plankton that are in, one of these little infinitely thin cross sections here, okay? So how would we do that? So we would take the area of the cross section, which is 3, multiply it by the little change here in the depth. So that would be dH. And then we'd also multiply it by the density, which is F of H. And that's how much, how many millions of plankton cells would be in one of these little tiny cross-sectional pieces here past 30. And then we want to add up infinitely many, infinitely thin of those, starting at 30 and stopping at K. There we go. And so that would be in millions of plankton cells. And this is the first thing that they asked for. I'm actually going to box it because that's the first thing that they asked for. They said, where are we? Write an expression involving one or more integrals that gives the number of plankton cells in millions in the entire column. This answer is that part, okay? Now, the part where here with the U of H and all this garbage, that's going to come in handy for the last part. Explain why the number of plankton cells in the column is less than or equal to 2,000 million. So for that part, then, I'm just going to continue on to this expression, okay? So I'm going to point out that this would be less than or equal to that 1,675 million. Plus the integral from 30 to K of 3 times U of H, dH. And why do I feel like that's okay? Because they said U of H is always greater than F of H, and they're both positive. So whatever area is underneath, say, this curve, it would be less than the area underneath. Oh, sorry, look where I'm pointing. The area that's underneath this curve would be less than the area that's underneath this curve. And then in addition to that, I feel like this would be less than or equal to if you're going from 30 to K, I feel like that would be less than going from 30 to infinity of the same function. There we go. And then, oops, this would be the same as pulling the 3 out. And then this would be, what did they say? They said that this integral right here is equal to 105. So that means that this would equal 1,675 plus 3 times 105. So 3 times 105 is 315, and 315 plus 1,625 is 1,990, which, my friends, is less than 2,000. Whoops, there we go. And that is the explanation, as that's us explaining why the number of plankton cells in the column is less than or equal to 2,000 million. Right there. Okay. And then this is a little embarrassing, but when I looked over the test, I didn't notice that part D here is actually from chapter 9. Which means that it's something that after we go through chapter 9 and all the material that we'll do after the AP exam, this will make total sense. But in the meantime, they won't test you over this. So this won't be on your test, on your AP test. Anyway, so I'll make a note of that on the assignment so people know to not stress out over it for now. And we'll also reduce the number of points, it looks like, by 2. So the assignment will end up being out of 43 points, I think, instead of 45. There we go. All right, my friends, I hope this was helpful to you. I know these problems are tough, but I always like practicing on things that are hopefully harder than what you'll have on your test, as opposed to things that are easier, so you don't get too surprised. All right, my friends, take care, everybody.